Okay, so this is just continuation of 5.5. So let's just kind of pick up where we left off. So let's do another little example here. Let's say let's find all zeros of f of x equal to x to the fourth minus 7x to the third plus 18x squared minus 22x plus 12, given 1 minus I is a 0. Now, because this is a fourth degree polynomial, we need 4 zeros. Okay? The complex conjugate theorem says that if the complex number is a 0, then its conjugate is as well. So we know that 1 plus I is a 0 as well. So we've got 2 zeros. We need to find 2 more. Okay? So let's go do synthetic division with this guy to simplify it a little bit. So doing synthetic division, you can go back and look at it, but those are the coefficients. Okay. So drop that 1 down, I get 1 minus I. Add just the real parts, we get negative 6 minus I. When you multiply those together, you can do it on your own, but to save time, I'm going to just go ahead and tell you what it is. It's negative 7 plus 5i. Add the real parts, get negative 11 plus 5i. Again, multiply, we get 16 minus 6i. Add the real parts, we get negative 6 minus 6i. And then multiply those parts, we will get negative 12 and 0. Now, the great thing about synthetic division is once we simplify it once, if we know another 0, we can just take these guys here and do synthetic division again right under it. So we get 1, and we get 1 plus I, which gives me negative 5. Multiply those, we get negative 5 minus 5i gives me 6, and that gives me 6 plus 6i, which gives you 0. So that was all understood that was going to happen because I knew that those were zeros. So to finish the problem, we need to take what's left over, set it equal to 0, and solve. It factors x minus 2, x minus 3. So we get 2 and 3 as the remaining zeros. Okay? Now, again, I gave you zeros for that problem. Let's say I just say find all zeros. And so this is kind of like the culminating problem for this whole section. So let's say I give you this. F of x equals x to the fourth plus 5x to the third minus 2x squared plus 60x minus 168. Well, we need to start somewhere. Okay? So the very first thing to do is find rational zeros with calculator. And like I said, I'm going to post a video on how to find it with the calculator. And when we do that, we find those zeros to be negative 7 and 2. Okay? So, if I take those, I already know those are zeros because I confirmed it with the calculator, but I can do synthetic division to simplify. Okay? So I get 1, negative 7, negative 2, 14, 12. negative 84, negative 24, and that gives me 168 and 0. Again, that was understood, that we knew that was going to happen, but we're just using it to simplify, because we can drop down to the next line and use the other 0 to simplify a little more. 1, 2, 0, 0, 12, 24, and 0. So what I'm left with is 1x squared plus 0x plus 24 equal to 0. That's what we got to do to finish this problem. And that's not 24, that's 12. Oops. Finish that. Get negative 12, square root of negative 12, which is plus or minus 2I square roots of 3. So for my polynomial, we had negative 7 and 2 as zeros. And then we have 2I square root of 3 and negative 2I square root of 3. And that's how we find all the zeros using the calculator, because technology always helps. Okay, so I'm going to go on and talk a little bit about graphing to kind of finish this section up. How do we graph these polynomials? So again, we have a couple more theorems here as far as graphing. First, we have turning points. Okay, so on turning points, it says a polynomial of degree n has at most n minus 1 turning points. Okay, that makes sense. If you look at something like x squared, we know it's a parabola, and so you can see it only has 1 turning point. If you look at something that's a cubic, it has 2 turning points. Okay? And our next little thing is multiplicity. Now, we already talked about multiplicity as far as zeros, but this is talking about with graphing. It says if a zero has even multiplicity, the graph touches the x-axis, and odd crosses. So if something has even multiplicity, let's say at that x value, it just touches. If it has odd multiplicity at that x value, it'll cross, kind of like that. Okay, and the last thing we need to talk about is end behavior. Okay, so given a polynomial in standard form, to determine the end behavior, we only need to look at the lead coefficient here. Okay, there's 4 possibilities. First off, we have even and odd degree. We can determine that by that n. Then, if the lead coefficient is positive and if the lead coefficient is negative. Lead coefficient positive, lead coefficient negative. So, with the lead coefficient positive on even, as x goes to infinity, f of x goes to infinity. As it goes to negative infinity, it goes to positive infinity as well. So that's going to look like this. If it's negative, it flips. So it looks like that. Okay, here. If it goes to positive infinity, this guy goes to positive infinity. If it goes to negative infinity, this guy goes to negative infinity. So that looks like this. And then the other guy, let me separate these two. As x goes to positive infinity, f of x goes to negative infinity, flips, and as x goes to negative infinity, f of x goes to positive infinity, so that looks like that. Okay? I know I ran out of room, I'm sorry. So let's do a rough sketch of this guy. Let's say I have f of x equals 2x to the third plus 5x squared minus x minus 6. If you go through the whole process like I just did, we can find the zeros, and the zeros are 1, negative 2, and 3/2. Okay? So we're going to mark those. Here's negative 2, here's 1, and here's 3/2. Okay? It's even degree, and the lead coefficient is greater than 0. It's positive. So that means that our end behavior looks like, I'm sorry, it's not even degree. It's odd degree. Sorry. So if we look at our little table, our end behavior looks like that. So we know it's down here and up here. And since it's odd degree, we know we have n minus 1, so 2 turning points. So you can see that we can draw this crossing here and here and have 2 turning points, and then it ends up with our end behavior going the other directions. This is just a rough sketch of how to graph these guys. They can get pretty tricky, but if you know all the different details like we've talked about, you can graph these guys. So that's going to end chapter 5 or section 5.5.